Welcome to NASA Edge, an inside and outside look at all things NASA. Today, joining us on the show is Kuhl, who's the Chief Engineer for Medley 2. Chris, thanks for coming on the show today.
You're welcome, absolutely.
We've been talking a lot about Medley lately. We've talked to several folks from your team, and I just want to talk about today the engineering challenges, because as great as all this footage is that we've seen, it's really impressive what you guys did for Medley and Medley 2. Tell me, what were some of the challenges you faced, even with Medley 1, putting instruments on the heat shield?
Yeah, so there are three areas that I can think of which are the challenges, and it starts with the design. Way back 6 years ago, we have to decide what measurements do we want to take, what analysis do we want to do with those measurements. So for instance, pressure and temperature. And once we figure that out, we have to determine what are the ranges of pressures and temperatures and heat flux that we want to measure. And so we have to use analysis to help us determine that, and what level of accuracy do we need from those sensors. And also part of the design process is the placement of those sensors on the heat shield itself and on the back shell, because we put those in strategic places so we can maximize the science.
Was there concern at all, even from the very beginning, that actually going through the heat shield might cause harm to the spacecraft? Because I know the spacecraft folks are very protective about the mission itself. So how did you approach that?
So that is really the number one priority. It's what called do no harm. So our number one priority was to do no harm to Mars 2020. And that was a really huge effort to prove that, because we have sensors installed all over the heat shield and back shell. We have wiring and harnessing going in a lot of different places, and in some areas we're only inches away from the rover and some other critical hardware. But those sensors require us drilling holes into the thermal protection system, and that sounds crazy, right? We want to drill a hole through your perfectly good heat shield. And it does sound crazy, but when you start considering, reasoned engineering and analysis and testing, and we do a lot of that. We do arc jet testing where we blast samples with hot air. You can show that this is feasible, and we convinced Mars 2020 to drill 28 holes through the aeroshell. 18 are on the heat shield and 10 are on the back shell. Most of those are filled with the same thermal protection system that we drilled out, and it has our embedded sensors, but there are 11 of them that are through holes. And that means that during entry, if our sensors on the inside break away, there could be potentially a blowtorch going from the outside to the inside of that aeroshell, and that would be a bad day.
Now, I understand that when you moved from Medley 1 to Medley 2 and added these extra sensors on the back shell, you didn't just add sensors. You mentioned it earlier, there was extra wiring and all sorts of additional supporting hardware. Did that make the challenge of separation from the spacecraft even more complex, since you basically added physical wire to the suite of instruments?
That's right. So similar to Medley 1, we have to go through a pyrotechnic cable cutter. To go from the heat shield to the back shell, not just to the sensors, but that's how we get to the rest of the spaceflight system. So we communicate and get our power from the descent stage. So we did have a couple of small wires going through that on Medley 1. On Medley 2, we added probably 10 times the amount of wires, or even more, going through this cable cutter. And this is a fixed size, and so we had to design the system accordingly. What kind of shielding are we going to use? What kind of wire gauge are we going to use to make sure that it not only fit, but that it was able to cut properly? And JPL did some testing on that as well, because again, if that didn't cut properly, that would probably be a bad day during the heat shield separation event.
Well, I'll tell you, I'm going to make a wild prediction and say if there's a Medley 3, I'm going to predict that you'll want more holes on the shell and you'll add more instruments on the back shell. Call me crazy, but I think that's just the kind of guys you guys are.
Yeah, so we always want more. The science folks always want more measurements, but we're also reasonable. We also know we have to live within constraints, and one of those constraints is budget and schedule. And so if we want an additional pole or sensor, then we have to show the value of that. And there is value in that, but we have to demonstrate that and then convince others that it's worth spending the money. And that's what we've done in the past, and it's resulted in a lot of successful data.
Awesome. Well, I tell you what, budget, schedule, and do no harm. You nailed the landing. We're very proud of you guys. Thanks so much for coming on the show today and sharing with us your experience with Medley 2.
It's my honor. Thank you so much.
You're watching NASA Edge, an inside and outside look at all things NASA.